So welcome back everyone for our day 5 of 100 days of ML. Today we are diving deep into the regression part of it, the logistic regression. And so we'll unlock the power of logistic regression today. And this is where we move beyond the predicting numbers to classifying things. And we'll explore how logistic regression acts as a gateway to classification and helping us sort the data into distinct categories. So let's get ready to understand the fundamental concepts of machine learning. So in day 4, we talked about different type of machine learning. And today we are stepping into the ML factory to actually see the logistic regression in action. So think of logistic regression as our factory sorting machine. So it takes raw data and sorts into clear categories, like separating spam from all the important emails. And this is our first step to binary classification as well, where we predict the probability of something belonging to one group or the other group. Like, so binary classification is something whether it is head or tail. So this is the starting of it. So we just learned how logistic regression sorts things. But why can't we just use linear regression for classification? So you might ask me a question, why can't I use linear regression rather than I need to use this logistic regression? So linear regression gives us the unbounded outputs. So which isn't what we need for probabilities, right? It doesn't give us the probabilities. We need an output that's always between 0 and 1. This is the squashing problem. So we need to solve this to get meaningful probabilities for classification. Now we just discussed this need of squash our linear output into probability. That's where the sigmoid functions come in. So these functions act like an activation gate, taking any number and transforming into value between 0 and 1. And this introduces our non-linearity part of thing, which is key for handling more complex classification tasks. So now let's see the squashed output helps us making some clear decisions as well. So we have got our probability from sigmoid function. Now we how do we actually make the decision? So this is where the decision boundary comes in. So we set a threshold like usually 0.5, and this 0.5 threshold turns that probability into a clear classification. So if the probability is 0.5 or higher, we classify it as a one thing, otherwise it's the other thing. So this threshold creates a line or plane in our data, which is our decision boundary. Okay, so it's the point where our model switches to its prediction. And this boundary is very crucial for understanding how our model separates different classes. And now, how do we know if our model makes a good calls or not? So for that, we have established log loss. So binary, or we can say binary cross entropy as well. So this isn't just any error metric. This is specifically designed for classification problem where we are predicting probabilities. So log loss really pushes this confidence, but it is incorrect predictions, right? So if our model is super sure about something, say 99% confident, but it's wrong, the log loss would be huge. Okay, and this forces the model to learn and adjust its weights and biases as well. Okay, so our goal is to minimize this log loss, which will help us find the best possible weights for our model, right? Now, let's summarize the thing. We have covered a lot today, laying the groundwork for classification with logistic regression. And it's the bridge that takes linear models and turns into tools like discrete classification. So we saw how sigmoid function squashes values into probabilities, acting as a probability squasher. And then we saw log loss that became our confidence metric, and which was telling us how our model is performing. And finally, the zero point 0.5 threshold gives us the sorting logic, creating the clear decision boundary. And this all components together forms the foundation for the understanding more complex classification model as well. Right. So thank you so much, everyone. Let's sum it up here. And We'll see you in the next day. Thank you.